This is MAT 175, Lesson 20, Section 5.6, Logarithmic and Exponential Equations. Now, in this lesson, we're going to take what we applied with properties of logarithms, and we're going to further learn how to solve logarithmic problems. In the past, we had said that the basic equation for logarithm is log x base a. And if we were to convert it to an exponential form, then we would have base a to the y power equals to x. And we can convert back and forth between logarithmic and exponential equations because they're inverses of each other. Well, here we can also state that log m base a, when that is equal to log n base a, as long as they have the same base, and we're working with log and log, then what happens here is your m is going to equal to your n. And where a is your base is all positive numbers that is not a 1. So here we have a logarithmic equation. And basically, we want to go ahead and we're going to, we want to go ahead and move this exponent up. And when we do that, then here, then what we get is we get log 4 base 3 equals to log x squared base 3, and since the logs are the same, then that's where we get that log a base a equals to log b base a, then a equals to b. So now we're going to take these log 4 and the x squared and set those equal to each other. And now we apply, just solve for x like we normally would, and we get here x equals to plus or minus the square root of 4, and so that comes out to be plus or minus 2. And so this is our answer. And that's what we get here. So the domain of the logarithmic functions is positive numbers only, so check for extraneous solutions. So it's really important that you check, make sure that you don't get any negatives in your logarithm. Well, in this case, because the 2 moves out front, we end up with a negative. So we can't use negative 2. Alright, so we just keep that in mind. Can't use that. Alright, so here we have log x plus 2 base 2 plus log x minus 1 base 2 equals to 1. So in this case, what we're going to do is we're going to condense these. And so this becomes log x plus 2 and then 1 minus x, and that's base 2 equals to 1. Well, basically this all becomes, this is all still under the logarithm. So in this case, we can go ahead and FOIL that, and so that would be log, and so we've got here x times 1, that's just x, and this will be minus x squared, and then plus 2, and then minus 2x base 2 equals to 1. And so we get here log negative x squared, and then this will be, got a 1x and minus 2x, so that's minus 1x, and plus 2 base 2 equals to 1. And so at this point we can convert from logarithmic to exponential form, and so this will be 2 to the first power equals to a negative x squared minus x plus 2. And so we can either, we'll go ahead and move everything over to the other side. So that'd be plus x squared and plus 1x and minus 2. And so the 2's, they're going to go to 0. And so we get x squared plus 1x. But at this point, we have to factor our common, in this case, common factor, which is x, and we get x times x plus 1, and so we get x equals to 0 and x equals to a negative 1. Well, when we put negative 1 in here, we get minus negative 1, that becomes a positive 1. We put negative 1 in here, and that's going to be a positive as well, so that's okay. And 0 in here and here, that's going to be okay, that'll be a positive, so those solutions are okay. And so here, this converted from 2 to the first power, that's this. And then they went ahead and FOILed, but it's basically the same thing. Alright. Solving. Now, we've known before that when we have a to the u equals to a to the v and the bases are the same, then you have u equals v, where a is greater than 0 and a cannot be 1. So we want to solve this equation. Now in this case, what we're doing is these two bases are not the same, but what we can do is we can apply either log or natural log base 10 or natural log to both sides. In this case, we applied natural log to both sides, but it really doesn't matter which one you use. And in this case, now we can move that x out front. And now from here, what I like to do is I like to go ahead and find what natural log 7 is on the calculator first. So natural log 7, that's going to be 1.9459, and it goes on, equals to x natural log 3. Well, we still have to solve for x, so now what we can do is divide by natural log 3 and divide by natural log 3 here. So on the calculator, you leave that 1.9459, you leave it there, you don't delete it or round it off or change it or any way. And then on that calculator, you just put divided by natural log 3 and hit enter. And we get x is approximately equal to 1.77124337, and it goes on. So depending on what you want to round it off to would be, what you would use. And so at that point, now this would be exact, but I don't like to calculate it this way, because what happens here is that students do not, sometimes they do not close the parentheses. If you're going to do it this way, you have to close the parentheses on the logarithm. So on the calculator, you would have to write it as, enter it as natural log 7, close the parentheses, divide by natural log 3, and then get in the habit of closing the parentheses there. If you don't close the parentheses, what happens is the calculator enters in this divided by natural log 3 in with this natural log here, and then the answer comes out wrong. So that's why I like to go ahead and find what the natural log 7 is first and then divide it. And then we get the same, they round it off to 3 decimal places. Okay, and so we get 1.771, and that's our answer. And if you plug it back, if you take this, don't round it off, set that, if you wanted to check it, you store this answer into x and then put 3 to the x power, and you'll get 7 when you check it. But if you round it off, then you're going to get something close to 7. Alright. Here we're going to solve But before we can do anything with this exponent, we have to get this base by itself. So we're going to divide by 5 on both sides. And so we get 2 to the x power equals to 3 over 5. And now at this point, we can either apply log or natural log to both sides. So we'll go ahead and apply log this time. And our calculator is base 10, so we use log base 10. Alright, and now we don't want that x. We can't solve for this as long as its x is up here in the numerator. Is an exponent, so now we can bring that down. And so we've got here x log 2. And now we can go ahead and find what log to the 3 over 5 is. And so we would put in here log 3 divided by 5. And we get a negative 0.22184, and it goes on. Negative 0.2218, and it goes on. Alright, now at this point, we can go ahead and divide by log 2. And divide by log 2 here. Okay, and when we do that, we enter in the calculator divided by log 2. And you want to get into the habit of closing the parentheses off. And so we get x is approximately equal to a negative 0.73, we'll call that 7. It comes out to 7369655, and it goes on. So we're going to round that off to negative 0.737. And so basically that's what they did here, divide the 5, and then see they used natural log, but we use log base 10, and the answer comes out to be the same. So here, this is where we would apply the natural log 3 over 5. Now they went ahead and put it natural log over 2. Now you can do it that way, but you got to make sure to close the parentheses off here. So if they ever ask for it in exact form, this would be exact form here, the natural log 3 over 5 over natural log 2. That would be exact, but you know, as a decimal, of course, that's going to be rounded off. And so they got the same answer we did. We used log base 10, they used natural log, got the same answer. Okay, now here, notice, the exponents have different bases. So we can't just set the bases are different. They're not the same. So we cannot set the exponents equal to each other because the bases are different. So we go ahead and apply. So I'm going to rewrite this. 2 to the x minus 1 equals to, I'm going to give myself some room here, 5, 2x plus 3, and we're going to apply natural log and natural log. And you could have applied log base 10 if you wanted. Really, you know, it doesn't matter that much. Okay, now, this is real important. You want to put parentheses here before you bring down those exponents. Why? Well, because what you have to do is you're going to have to distribute. And if you don't distribute, then it comes out wrong. Okay, so this is x minus 1, close parentheses, natural log 2 equals to, and then here we have 2x plus 3, close parentheses, natural log 5. Okay, now we're going to distribute. Okay, so this is going to be x natural log 2 minus 1 times natural log 2, so that's just natural log 2. And then here we're going to distribute the natural log 5. So this will be 2x natural log 5 plus 3 natural log 5. Alright, well, at this point, what you want to do is you want to go ahead and you see how you have numbers in front? You want to go ahead and move them up as an exponent. Leave the x's down there, but the numbered exponents, they're going to move up front, up as an the numbers in front, they're going to move up as an exponent. So we have here x natural log 2 minus natural log 2 equals to x natural log 5 squared plus natural log 5 cubed. Okay, well, we still have a problem here in that we've got two x's, and we want to go from 2x's to 1x. So what do you think we got to do at this point? Okay, you should have said we need to get them over to the same side and combine like terms. So what we're going to do here is we're going to apply a plus natural log 2. We're going to get that over to the other side. Plus natural log 2. And we're going to apply a minus x natural log 5 squared. Minus x natural log 5 squared. So what we have here now is x natural log 2 minus x natural log of that 5 squared, that becomes 25, equals to natural log 2 plus natural log the 5 cubed becomes 125. Alright, now we have a common factor that we can factor out. And so that'll be x and then parentheses. And we have natural log 2 minus natural log 25. Okay, and now here we can go ahead and condense that. And that'll be natural log 2 times 125. And so that's going to be 250. Alright, so this will be, and then this will be the left side, that'll be x, and we get natural log, now this is 2 minus, this will be natural log 2 minus natural log 25, so this will be natural log 2 over 25 equals to natural log, and so now 2 times 125, that'll be 250. Okay, so now we can go ahead and find what natural log of 250 is. So natural log of 250, that comes out to be 5.52, and it goes on. Okay, so this will be 5.52 dot 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 dot, it goes on 5.521460918, but we're just going to put 5.52 and then put the dots after it to show it continues. And so we'll bring the x natural log 2 over 25 down. And now what do you think we're going to do? And you should have said we're going to divide natural log 2 over 25. Divide natural log 2 over 25. And we get, so we still have that 5.521460918, and it goes on there. We didn't delete that or anything, and now we just hit the divide by natural log 2 divided by 25, and we get here a negative 2.18608, and it goes on. So this is approximately equal to a negative 2.186086352, and it goes on and on and on. It's an irrational number, and so we're just going to round that off to negative 2.186, and now that's our answer right there. So if you could take that number, store it into x, and store it into x, and hit enter, and go back and check it, you'll see that both sides should equal. Alright. And so basically that's what they did here. They apply, okay, they use natural log as well. But again, you could have used log base 10 also. Bring the parentheses down, and then they distributed, and so on. Went through it, and we got the same thing. Okay. Now they didn't condense it. Now you can do this, but you have to be careful with this, and you have to close the parentheses. And same thing with the denominator, because if you don't close the parentheses on this, what the calculator sees is this: 3 natural log 5 plus natural log 2, right? And then divided by natural log 2 minus 2. So it only calculates these two, the first and the last together, and the two middle get divided, and the others don't. And so you end up with something completely different. So you've got to make sure that you close the parentheses if you're going to do it this way. Okay? Alright. And now this next one here, we want to go ahead and we want to get the bases to be the same. So here 9 x squared is the same as 3 squared, okay, to the x. So that would be, since this is 2 times x, these exponents would multiply, right? You would get 2x as an exponent. And so from here, I'm going to back up. Back up. Okay, so from here, what we're going to do is this changes to 3 to the 2x power minus 3x minus 6, like that. And actually, you know, if you wanted to leave it as x and then parentheses squared like that, you know, that would be fine too. And then what we could say at this point is that 3 to the x power, we're going to assign that to u. So we're going to substitute u in for 3 to the x power. And so when you do that, then you get u, this becomes u squared. This first term becomes u squared minus u, because the 3 to the x is u. So now this is just 1u minus 6 equals 0. Okay, so we've substituted the 3 to the x power for u. And so this 3 to the x power, that becomes u, and that's where the u squared is. And then minus, and the 3 to this x, so that would be just u there, minus 6. And so now we go ahead and factor, put u and u here, and plus and minus, and we're going to put 2 and 3. And let's see, that'd be negative 3u and plus 2u, that gives us a negative 1u, so it checks. Okay, and so that'd be, now we set our factors equal to 0, and we get u equals to negative 2, and u equals to 3. Now, since we said that 3 to the x is equal to u, we can substitute this 3 to the x power back in for u. So this is our 3 to the x equals u. So now this will be 3 to the x equals to a negative 2. And so at this point, if we went ahead and applied natural log to both sides, okay, what happens? Natural log or log, either way, what happens here? Well, we get a negative natural log, right? And so at this point, can't use that. So that's no good. That's out. Alright, so now we have here 3 to the x, change the u to 3 to the x power, equals to 3, and again, you can either change it to, you know, logarithmic form or apply log to both sides. It really doesn't matter. We're just going to apply natural log to both sides. Okay, and then what do you think we're going to do here? You should have said we're going to bring that x down. So we get x natural log 3 equals to natural log 3. And so we divide natural log 3 to natural log 3, right? And, well, natural log 3 over natural log 3, anything over itself is 1 except for 0 over 0. And so we get x equals to 1. And so that's what we did doing here. And so we got our extraneous solution for the -2, and we got 1 over here. And you could have also used properties of exponents here, because the bases are the same. This, we could say that this is 3 to the first here, and then at that point we could have just said x equals to 1. Done it that way too. Okay, and that concludes our lesson, our video lesson for today.